Hey everybody, Chief Meteorologist Brad Panovich here. I want to do a quick little post on this because this is an incredibly frustrating situation that continues to happen in the Charlotte metro area because of our lack of Nexrad Dual-pol Doppler radar. The tornado that happened on Monday was in one of those spots where it was close to the terminal Doppler radar, which is great, but there's less tools at your disposal with the terminal Doppler radar. You get velocity data, you get reflectivity data, but you don't get all these dual pole products like debris detection with correlation coefficient and other products. And it's a weaker radar that has attenuation issues. It tends to get, basically rain fade. Now, thankfully, this storm happened close to the radar, and without this radar, we probably wouldn't have seen it at all. But I want to show you even the limitations with this radar for everybody who continues to make the ridiculous argument, oh, we've got a terminal Doppler radar, that's fine. Then rip out all the 88Ds and put terminal Dopplers in. If the 88Ds aren't good, then take them out. If they're not, if terminal Dopplers are great, you don't need 88Ds. But nobody will make that argument because it's a silly argument. This is a radar that helps. It doesn't completely solve the problem. It's a band-aid for a gaping wound. We need better radar coverage in the Charlotte area. And just to highlight this, even this radar, which is thankfully there that everyone praises, thank goodness we have a terminal Doppler, it crapped the bed on Monday because there was a huge 7-minute gap in velocity data for some odd reason. It was on our system at the station, WSI. It was on, you're looking at Radar Omega. I looked up Radar Scope, which I have data feeds from the government, from Radar Scope directly, which is DTN, directly from Allison House. So different data sources. So it clearly was a government feed issue, not one of these data providers, because watch what happens. So this is the timeline of the tornadic storm. You see it moving over Cotswold to my left of my head there. I'll stop it. Right here is our developing tornado. I'm watching this on radar, and I'm noticing there's a big discrepancy between the reflectivity and the velocity data. Now, these times I don't think are exactly right, but there's clearly a gap in there. But this was basically around 1:30. So if you look at the reflectivity, it's a little more accurate here. But watch what happens as we go to about right here when it starts producing a tornado near Reedy Creek. So right here, this is around 134, 141, we start getting reports of damage. So this is about when it touched down. There was not a warning out yet, by the way. There was one beginning to, and we actually went on the air. We were already streaming saying, hey, there's a developing tornado here. But the warning came out just shortly after. But watch what happens here. This is basically at 141. Okay, it spins up. I got one more frame of data, and then one more frame of data. And then look at what happened here. It jumps, right? There's a 7-minute gap. For some odd reason, between 1:34 p.m. and 1:41 p.m., the velocity data stopped feeding from the terminal Doppler radar, which look at the difference. I mean, that clearly you could see the rear flank downdraft surging out, which is going to form tornado genesis, basically kicking tornado genesis, which is actually what I started seeing right here on the air and said, uh-oh, we've got a tornado developing here. But look what happens. There's a 7-minute lack in the data. That's crucial. 7 minutes that we could have had 7 scans of the radar to let us know what's going on. And then clearly near, there's a tornado. I mean, we're on the air, the warning's popping up. The warning came out from the Weather Service here. And then you see it really start to crank up as it's moving through Rocky River Road area and then moving into Harrisburg. Clearly that's a tornado right there. But the hard part about this is thank goodness we have this radar, but even it has its fallacies. It has the velocity data drops out for 7 minutes for some odd reason. We don't know why. And we don't have CC values. If we're looking at this, it starts causing damage. If you got a quad panel up at the Weather Service or in my office and you see lowering CC values or you see differential reflectivity starting to kind of go up there, you're starting to get, oh, there's something happening. We're getting damage occurring. But it just highlights the issue that, yes, I am glad we have this terminal Doppler. Thank the Lord we have it. But it's not the perfect fix. It is not. This radar was meant to be a 24-hour weather surveillance radar for us. The FAA installed these for wind shear detection, which they do a great job of, and downburst detection near the airport. But now we're using them for these big areas like this, and we're having struggles looking at these tornadoes. And also notice the possible, tornadic cell that moves towards Albemarle right here which probably was a tornado as well. We'll have to survey that, but out in that area. But just want to show you that horrible frustration we had with the radar data dropping out. 7 minutes of velocity data randomly drops out from the terminal Doppler. Thank goodness we have it, but just another highlight the fact that we need better radar coverage in the Piedmont of the Carolinas.